Okay, one more example here for us. This is on the next page of your notes. Okay, and this time I have the linear inequality y is less than negative 3x plus 1. Okay, so the first thing I do is I say to myself, well, I know that this linear inequality has a boundary line, and the boundary line, or the boundary, is the line, and I'm simply going to put an equal sign in there. Okay, so y is equal to negative 3x plus 1. That's going to form the boundary of my linear inequality. Okay, and so there's my b value. B is equal to 1, so the line crosses the y-axis at 1. Y equals 1. X equals 0. Okay, there's my b. The next thing I do is I look here for the slope. The slope is equal to negative 3, and I know that's the same as negative 3 over 1. So that tells me my rise is negative 3. So that tells me to go down 3, okay, and over 1. So my rise here, I'm going to go down 3. So for every 1 change in the x, I have to go down 3 on the y-axis. So down 3, 1, 2, 3, over 1. Okay, down 3 over 1. Sorry. Okay, down 3, 1, 2, 3, over 1. All right, perfect. If I wanted to put some points in the opposite direction, okay, above B, I just have to think about it, and I have to reverse the order here. So I'm going to go up 3, 1, 2, 3, back 1. Okay, up 3, back 1. That just gives me a few more data points to connect. I don't see any restrictions given here. Okay, so I can assume that this solution set is continuous. So I'm going to assume that there are no limits for x or for y when I draw this boundary line. Sorry, y. I'm going to assume that x and y are members of all the real numbers, which means that I can continue in both directions. The other thing I need to look at here, and I have to ask myself before I draw the line, do I use a solid or a dashed line? So I go back to my inequality, I look at this, I see that it is going to be this is a strict inequality, I'm going to use a dashed line because there's no possibility of y being equal to negative 3x plus 1. Okay, so the possible values of y will not fall on the boundary line. So I cannot use a solid line. That indicates that y could be on, a value for y could be right on the boundary line, and that's not true. So I'm going to use a dashed line. So I'm going to connect my data points here with a line, but it's going to be dashed, just like this. And I'm sorry, I really, it's hard for me to draw a straight line here. I hope that yours is much straighter than that. Okay, good. So there's my dashed line. Now I have to ask myself, which side am I going to shade? And I come back again to that same inequality sign, and I see that y is less than, okay, y is less than the boundary line, so I'm going to shade. I'm going to shade below the boundary line. Okay, so shading below, I'm going to shade to the left of it, below the boundary line. You might, if you're wondering, on some graphs, I think shading above or below is it's very clear which side to shade. If you have any questions about which side do I shade, above or below, maybe you're not sure to shade to the left or to the right, there is a quick way that we can figure out which side to shade. Okay? So we can use what's called a test point. A test point is exactly what it says. It's a point that we pick and we use it to test and see if that point is included in the inequality. So you choose a point to test. The best point to choose, the easiest one to choose, is the origin, the point 0, 0. That's a great one to choose. You're going to take 0, 0 and you're going to substitute it in to your linear equation. Okay, so when I say test 0, 0, we're going to substitute x equals 0 and y equals 0 into the linear inequality. Okay, if the test point solution to the inequality if the test point 0, 0 is a solution, okay, then we will shade the half plane that contains that test point. If it's not a solution, then we'll shade the other half plane. Let's do it for this example that we just did, okay? So here we've got y is less than negative 3x plus 1. I'm going to substitute in 0 for x, pardon me, 0 for y and 0 for x here. Okay, so it's going to look like this. I've got 0 for the y, okay, less than negative 3 times 0 plus 1. So I get, let's clean this up a bit. We have 0 is less than, negative 3 times 0 is 0. This is gone. Okay, all I have is positive 1 here. That's all that remains. Let me look at this statement. 0 is less than 1. That's true. Okay, so the point 0, 0 is a valid solution. Okay, so that means that the point 0, 0, okay, is going to be contained in the shaded region. If I had gotten an answer that was not true, okay, then I would shade on the side that does not contain the point 0, 0. So if we go back here and have a look at the graph that we just did, if you use the test point 0, 0, so if this is the test point that we chose, 0, 0, and you can use any test point. You don't have to use 0, 0. It's up to you, but it's an easy one to use. Easy to substitute in. So there's my test point. When I checked that test point into my linear inequality, it gave a valid solution. So I'm going to shade the side or the half plane that contains this point, and that will be the half plane on the left of the boundary line. Okay, because 0, 0 is on the left-hand side of the boundary line, okay, or below. All right, so let's do a quick summary then of what we've talked about here. We learned how to draw the boundary line in. So when we see something like this, for example, okay, y is less than, that tells me that my boundary is going to be a dashed line. Okay, dashed line. If y is greater than, same thing, a dashed line, because there's no possibility of being equal. On the bottom there, if I see that y is less than or equal to, I am going to use a solid line because there is a possibility of being equal. And the same is true if y is greater than or equal to. I'm going to use a solid line. The solution set then for each one of those inequalities, for the first one, if there's no possibility of y being equal, okay, if you're using a dashed line to show your boundary, that means that y cannot have a value that is on the boundary line. Okay, so the solution set, let's go up here for a minute. The solution region, okay, is the part of the graph that represents the solution set for the linear inequality. So those are values for x and y that satisfy the linear inequality. Okay, so those are points that if I substituted those values for x and y into my linear inequality, I would get a valid solution. Okay, so if we have, when we have strict inequalities, have no possibility of being equal. So y is less than or y is greater than are strict inequalities, and the solution set is the shaded region only, or the shaded half plane. Okay, so the solution set cannot include the boundary. Let's write that down. The solution set cannot include the boundary line. Okay. However, if we have a solid line, which means that our inequalities are not strict inequalities. There's a possibility of y being equal to the value on the right-hand side. Then the solution set, okay, will include the boundary and the shaded region. So that means that there's many possible solutions. A linear inequality doesn't have one solution. Okay, there's many possible values of x or y that could satisfy that linear inequality. If it is an inequality like this, okay, on the bottom, y is less than or greater than, then those values could be on the boundary line and they could also be in the shaded region. Okay. However, if it's a strict inequality, they can only be in the shaded region. Okay, the boundary is not part of the solution set. Let's go back for a moment. You can see on the bottom of your notes I wrote, let's go back to the graphs we just drew and let's define the solution set. Let's do this very quickly so that it really helps you understand what is the solution set for each graph or at least each linear inequality. Okay, so I'm going to get you to flip back for a moment. Okay, just to this example here. So if you flip back 2 pages in your notes, let's look at the first graph that we did. Okay. So the first example here. So the solution set for this one, because I have a solid line, it would be the shaded region and the boundary. So let's write that down. I'm going to write that over here to the side. Okay. So the solution set is the shaded region and the boundary. Okay, the shaded region and the boundary. Lower down on your page, on the next graph, again, the solution set is going to be the shaded region here and the boundary. Okay, so let's write that here. The solution region, the solution set is the shaded region and the boundary. Okay, and that's because y was less than or equal to x. That means this is not a strict inequality. That means that any point that is a solution for that linear inequality could be found here, for example, okay, or here, in the shaded region, or it could be a point right on the line itself. On the next page, the last one that we did, we had a dashed line. This was a strict inequality, so the solution set for this is only the shaded region. So the shaded region only. So there's no possibility that a point on the boundary line could satisfy this linear inequality. Okay. Great. That completes our notes for today. I hope that that was clear for you. And the questions that I'd like you to do then for homework for this section are on that 6.1 worksheet, Graphing a Linear Inequality. And you'll notice that the answers are at the back of the worksheet. Okay, so you can check all of your graphs. You're asked to graph a few different linear inequalities, and you can make sure that your graphs are correct by looking at the back. All right, great. Thanks for joining me today, folks. We'll see you next class.